Greetings and welcome to lesson 10.4, page 422, 423, and 424. Hopefully you have read those 3 pages prior to watching these video notes. It does make a difference. Today we're going to continue with probability and statistics by finding the number of outcomes of compound events. Okay? How can you find the number of possible outcomes of one or more events? All right? So let's find out. So you were first asked to take a few notes on sample space. Well, sample space is nothing more than a list of all the possible outcomes or combinations. Okay? That's what it is. And one of the best ways to do that, well, especially when the sample space is small, is a tree diagram. And that's what we're going to do first. We're going to do 2 of those examples. So let's start off with a tree diagram as a way to find out how many possible outcomes and make a list of the possible outcomes so we can see them all. All right? It says here each spinner is spun once. Draw a tree diagram to determine the number of possible outcomes. So, well, if we have 2 spinners, then we have 2 events. So we have event number 1, and that's the first spinner. And then we have event number 2, which is the second spinner. Now, if you don't, I know on your copy you can't really see the colors, so you might want to add colors or even numbers if that's what you wish to do. So I'm going to just do it with the colors. So if we have the first spinner and we spin it, let's list the possible outcomes. We did that in our first lesson, listing the possible outcomes. Well, the possible outcomes are what? Blue, we have red, we have yellow, and we have green. Those are the possible outcomes. That's it. Then we go to our second event. When I do my second event red, and we recognize that if in the first event we spun and we got blue, what could our possible outcomes for the second event be? Well, we could have red, we could have blue, or we could have yellow. If our first spin was red, we could also have red the second time, blue the second time, or yellow the second time. For yellow, if we spun yellow the first time, the second time we could get red, blue, or yellow. As you can see, it can get kind of messy when as it's getting bigger. And on the first roll, if it were green, we could still get red, we could get blue, and we could get yellow. So listing our possible outcomes, I know there's not a lot of space. I apologize. After I photocopied this, I'm like, I should have given more space. It is what it is. So listing our possible outcomes of spinning both spinners, we could have blue and red. That's right here, first at the very top. We could have blue and blue, and we could have blue and yellow. Or we could have red then red, red then blue, or red then yellow. Or we could have yellow then red, yellow and blue, or yellow and yellow. Or we could have green red, green blue, or green yellow. So there's the possible outcomes. We could count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes, and we've listed what each one of them would be. Then we did that way back. And this is by listing it with having more than one event. One more time, and I really didn't give you any space to do this one. So if you go to the very back of your insert, and the very back page, example number 9, and then you can cut that big space in half. And if you cut it in half and then write example number 2, you can put it there. That would probably be the best place. But let's read first. It says a local bike shop has a special dynamo bike, a special on dynamo bikes. You can choose your style, either mountain or 10 speed, your color, red, black, or green, and you can choose your size, 26 or 28 inch. Use a tree diagram to determine the number of different bicycles offered. So once again, we're going to have some events. The first event is going to be style. The second event is going to be color. And the third event is going to be size. I guess I didn't put event 1 there. So there's only 2 choices for the style. For the style, we could have a mountain, or we could have a 10-speed. And as you can see, you got to try to figure this out because each one, this tree just gets bigger and bigger and more crowded, more crowded. Let's use a different color for event number 2, color. So if I chose a mountain, I could have red. I could have, red, black. I'll write out the word. Or I could have green. And of course, if I chose a 10-speed, I could also have red, black, or green. And then I get to choose my size. Let's go with even a different color for size. So if I chose a mountain bike that's red, I could have 2 sizes, 26 or 28. If I chose a mountain bike that was black, I could also have a 26 or a 28-inch bike. And if I chose a mountain bike that was green, I could also choose a 26 or a 28-inch size. 10-speed, red, I could have 26 or 28. 10-speed black, 26 or 28. And a 10-speed green, 26 or 28. Listing all my outcomes, I got mountain, red, 26, mountain, black, 28, mountain red, 28. Then I have mountain black, 26, mountain black, 28. I have mountain green, 26, mountain green, 28. I have 10-speed red, 26, 10-speed red, 28. 10-speed black, 26, 10-speed black, 28, 10-speed green, 26, and 10-speed green, 28. So as you can see, man, if we had much more options, doing a tree diagram could get very, very crazy. So there are advantages to doing a tree diagram. You can see each and every single outcome and how it occurs. However, a disadvantage might be if you have a lot of events or you have too many choices, it might get kind of hairy to draw. So let's go on to what we call the fundamental counting principle. You need to pause if you have to and take a few key notes on the fundamental counting principle. But basically it says, hey, multiply the number of ways each event can occur. All right? So let's do it. Oh, I already wrote that down. How awesome is that? Multiply the number of ways each event can occur. So, example number 3, determine the number of different ways a person can buy a bicycle from example 1. Well, if you remember, we had style. There were 2 ways, right? There was the mountain and there was a 10-speed. So there was 2 ways for the style. Then there was the color. And there were 3 different colors, red, black, or green. So there was 3 of those. And then we had the size. And there were 2 sizes, 26 or 28. If I go 2 times 3 times 2, I get 12. That means there's 12 ways 12 different types of bikes I could buy. And if we went back here and counted these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 ways. So the fundamental counting principle multiplies the number of ways each event can occur. The number of multiplying the number of ways each event can occur. Our next example. In the United States, we have radio and television stations, and they use call letters. All call letters start with either K or W. Okay? How many different call letters with 4 letters are possible? So how many events? First, you got to decide how many events. And there are 4 events, because you have to have 4 letters in your call letter. All right? So you have event 1. You have event 2, event 3, and event 4. Well, the first one is pretty stuck. You have to have either K or W in the first one. So there's only 2 possibilities. Now in the second event, well, how many letters are in the alphabet? That's right, 26. How many letters in the alphabet for third event? That's right, 26. How many letters are in the fourth event? That's right, 26. So when you multiply 2 times 26 times 26 times 26, guess what you get? That's right, 35,152 possible different ways of having call stations for either radio or television. That's a lot. Moving right along, find the total number of possible outcomes of rolling 5 number cubes. Hey, what game do we all play? That's right, Yahtzee. And you got to roll them. And if you roll it once, how many total different outcomes can there be? Well, you have roll 1, roll 2, or the first dice, excuse me. It's 1 roll. That's the first die, the second one, the third one, the fourth one, and the 5th one. And how many possible outcomes are in each one? That's right, 6. So 6 times 6 times 6 times 6 times 6, there's 7,776 different outcomes, different combinations of numbers you can roll when you roll 5 number cubes at a time. That's a lot, 7,776. Last one, how many different outfits can you make if you have 5 t-shirts to choose from, 3 pairs of jeans to choose from, and 3 pairs of shoes? I'm sure you guys have much more than that in your closet, and you can figure out how many different outfits you can make just by counting up the different things. But we're going to go with event number 1 is the shirts, and there's 5 of those. And then you have the jeans, and there's 3 of those. And then you have the shoes. The shirts, the jeans, the shoes, those are the events. 5, 3, and 3. Those are the number of ways that you can choose, the number of outcomes that you could choose your shoes, your jeans, and your shirt. And when you multiply all that together, you get 45 different different outfits. That's a lot. Just from that, I'm sure you guys have more. That's more than you can wear in 1 week by far. Alrighty, so 2 quick rights. Quick right 1, A and B. The first one, draw a tree diagram to determine the number of outcomes of tossing a nickel, dime, and a quarter. So you'll have 3 events. Event 1 is probably the nickel, event 2 would be the dime, and event 3 would be the quarter. And then part B, a cafe offers 5 kinds of tea, served hot or cold in sizes small, medium, or large. How many different ways can you order your tea? So I would use the fundamental counting principle on this one, the fundamental counting principle. Ladies and gentlemen, when you're done, take a quick break, and then come back and see us for video number 2.